All right, morning everyone. So welcome back to another Sunday morning session. Today, what we are going to learn is we've been doing measurements for last 2 or 3 sessions now, right? So today we are going to cover bits that we've not done so far. So we've done perimeter, circumference, area. We also did volume, etc. Right. So today we are going to do surface area, and I will touch upon some time-based questions as well, right? So time is also part of measurement. Before I kick off, just the rule of hygiene. Please do not distract the class. If you were somehow not able to hear me for any reason, it is technology at the end of the day. I will let me know on the chat, right? And I can fix it up, right? It is technology, it can go down. If you're not able to hear me all of a sudden, you're not able to see my screen, then probably it is, a problem at your end. Better rather than fixing it, log out, log back in, I'll let you in, right? Simple. Uh, Only chat when asked, right? Please don't spam. It takes a lot to do these sessions every Sunday. So respect everyone's effort and time. A few more people in. All right, surface area. So when we come to surface area, it's got two parts to it. The word surface and the other word is area. Now, area is a two-dimensional measurement. It's a 2D measurement. You all know that. Now, when it comes to surface, surface means anything which are the outer covering of a three-dimensional object. Basically, the outer covering, and that could be as layman as it could get for me, right? The outer covering of a 3D object. So what we are trying to do is we are trying to find the area of this outer covering. When I say cover might not be the great word, but think about this. Let us say we have uh, let us say we have a rectangular shoebox, should I say. So how many faces shoebox has? 6 faces, right? So I'm making those faces one by one. I've drawn 2 faces. That's how I've learned back in my school days to draw a cuboid. We call it as cuboid or a shoebox. Then here comes your third face, which is this bit here. And here comes your fourth face here. And then here comes your fifth and sixth face. So you're basically 6 faces. So the outer portion is nothing but these 6 rectangles, which together join up to make this box. These rectangles are nothing but the surface, the outer surface of the shoebox. Now, each of them being a rectangle. So what is the area of rectangle? Area of rectangle is length times width. So essentially, there are 6 rectangles coming together and we are just adding their areas up. So you should have 6 times length times width. That is nothing but the surface area of a rectangular shoebox. What have we done? We've just looked at how its outer surface looks like, what geometrical two-dimensional figures it has. So in this case, it has rectangles. How many? Six. And then we found the area of one rectangle, timed it by six. This is how you measure the surface area of any particular 3D object. Now, we talked about this is not truly right, but from an understanding perspective, yes, you can. Now, why this is not right? Why this is not right? Let's make it again. Now, this is the length of the rectangle. This is the width. So now I have two rectangles bang opposite to each other with same dimension, length and width. So these two rectangles area of these two rectangles can be added together. Let's do it. Length times width plus length times width. Awesome. We've added the areas of two faces marked in red. All right. Now, let's take another color and say, let's pick up the vertical faces. Let's pick up this face and this face. Now, this portion, this one that I've just mentioned, I've not named it yet, right? So let's say this is I call it as the height of this rectangular box. So these two sides are equal. Since this is W, this has to be W as well. And exactly opposite to it is another side, another face. Now I have marked two rectangles in green. What is the area of rectangle? Length times width. Here, the width is acting as length. So I only have two dimensions here, W and H. One of them is now length and the other is now the width. Forget about the letter that I'm using. So now I've picked up another two faces in green. The areas are H times W plus H times W. So now I'm done with four faces in total. Now, last but not the least, let me take, where can I take this? These faces here. This face, which would be probably this face here, this face here. The face that is in blue, the two faces, the front face and the face right at the back. What do I have? L and H as their length and width. So another two faces are length times height plus length times height. So now I have added all six faces and their respective areas together. So what is my total area? Surface area. I've calculated the individual areas. What is my total surface area? Total surface area. It is length times width plus length times width. And probably I'll use algebra more, right? LW plus LW plus HW plus HW plus LH plus LH. So finally, I can collect the like terms. 2LW plus 2HW plus 2LH. And I can factorize it as well. I can take 2 out. That is the total surface area or the surface area of a rectangular shoebox. A rectangular, should stop calling it a shoebox, it is rectangular prism. It's a rectangular prism. Now what if this rectangular prism becomes a square prism? So the rectangular prism becomes square prism. So what I'm trying to say is that now rather than a rectangle, you've got a square. Which means all sides are same. So when all sides are same, I stop calling them length, width, height. I just call them side. That's about it. Or a lot of books says only length. Right? This is S. They're all S across the board. They're all S. So the surface area for a square prism is 6 times. What is this? So now, if you look at it, let's convert this formula here. Now, all of them are sides now. They're not. So L is also side, width is also side, height is also side. So what this becomes is S square, because S times S makes it S square. So this is S square, 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 which is 3S square makes it 6S square. That is the surface area of a square prism. Easy peasy, right? So far so good. All right. Let us understand another figure, which is called a triangular prism. Now I'll take a snippy probably. I'm not too good at drawing triangular prism, honestly speaking. Let me show you what that is. That's a triangular prism. Now, how many faces does a triangular prism has? Anyone has any idea? How many faces a triangular prism has? Yes, 5 faces. What are those 5 faces? Let's quickly check, right? We've got a two triangles at the two triangles, two triangles, and then if I change maybe the color, 1, 2, and the front face 3. 3 rectangles. So it's got 5 faces, 2 triangles, and 3 rectangles. The base, the base is the triangle. And that is why it is called triangular prism. All right? Okay. Now, how does it look when I open the faces of this triangular? When I open the triangular prism, how does it look? Let's quick. I've got a beautiful snippy here I can share. When we open this up, that's how it looks. 5 faces you see here. We've got 2 triangles. When you open that up, so when you open a 3D object, it becomes a 2D object, right? And that is why we're talking about the surface area. And you've got 3 rectangles. So surface area of this triangular prism should be very, very straightforward. If I find the area of this two triangles, then they are exactly the same. So if you find the area of this triangle, times it by 2. So you find the area of 2 triangles plus the areas of remaining 3 rectangles. And that is the surface area. Simple, right? No dramas. Is this clear, everyone, so far? I know a lot of you might have know this, but a lot of you don't know either. This is new for you. Is this clear to everyone so far? I've just sort of simplified it to the best of my capacity. Yes, everyone, can I see a yes on the chat? Yes, no, yep, simple, right? I'm going as slow as possible, right? Okay, let's try to find out the surface area of this triangular prism. So let me pick up this triangle first. I'm picking up this triangle. 4, 5, and 3. So area of the triangle is half base times height, which is 6 meter cube. So this bit is 6. And exactly opposite to this will also be 6. So the area of 2 triangles is twice the 6, which is 12 meter cube, meter square. 12 meter square. Now let's find out the rectangles. Let's pick up, let's pick up this one. And I'll take this off so that we can clearly. Let's pick up this rectangle. This bit is equal to this bit. This is 7. So the red triangle, or red rectangle is length times width, 7 times 5. I'll call it as rectangle 1, R1, which is 35 meters square. Let's pick up the second rectangle. I'll change maybe the color. Is this bit. And if you look at the image, and I'll probably just take it off for a second. Look, this is the two small cuts. So this is telling me this is 4 because they are equal. That's the way in geometry that tells us they're equal. So rectangle 2 is length times width, 7 times 4 is 28 meters square. And let's look at the third one. I'll change the color, and you see here, you've got two cuts here. 3. So this is 3 now. And this is 7. So rectangle 3 is 7 times 3, 21 meters square. And now I've got everything that I need. I have the area of two triangles, which is 12. So the surface area is 12, which is the areas of triangle, plus rectangle 1, plus rectangle 2, plus rectangle 3. And that is 96. That is how you calculate the area of a rectangular prism. So any figure that's given to you, 3D object that's given to you, just divide them into independent faces, find the areas of those independent faces and add them. As simple as that. All right, with that in mind, probably I will throw one question at you and we see how you go. Right. Let me take a snippet. Probably I'll make some space here. Here you go. Can you find the area of this triangular prism? Go for it. All right, I'm seeing the answer now. 86 centimeters square. 86 centimeters square is the right answer. Okay, how have we done that? Let's quickly do it. So what we have here is we've got two triangles and again three rectangles. The two triangles, let's pick up the first triangle. The height of the triangle is 3.5. So half 3.5 times 4. And I times it by 2 because there are two triangles. Then the three rectangles. So we've got rectangles as everything is 6. You see here, everything is 6. So rectangle 1 is 6 times. So everything is 6 and 4. My bad. Yep. So 6 times 4 plus 4 times 6 plus 4 times 6. We've got three rectangles. Rectangle 1, rectangle 2, and you just add them. You simply add them, and it becomes 86 centimeters. All good? The ones that have doubles in it are 4, and the ones that haven't got 6. So you've got 2, 6 and 4. Cool. 86 is the right answer. Okay. Let's maybe do a quick, easy one, right? Let's do an easy one. Let's try this one. A rectangular prism. Go for it. Six rectangles in total. One 1.9 meters square is the first answer that I've seen. Can others validate it? Six rectangles, just join six rectangles, area of six rectangles, and you should be fine. Yes, now I think everyone's sort of getting the same answer. Yes. So that's length, that's width, that's height. So 2 times length times width plus width times height plus height times length. Solve it and you get 1.9 meters square. Simple. All right. Okay. Let's now go to another important 3D figure, which is cylinder. Now, if you look at a cylinder, Maybe take a snippy bit how it looks. That's how a cylinder looks like. Now, this cylinder has three faces. And when I say three faces, if we open this up, if you open the cross section, how it's going to look, I'll quickly show you. That's how a cylinder looks like when you open it up. So you can now clearly see what's happening. And we can now find the surface area. If you look at it, it's got the two faces, top and bottom, are actually circles. See here, circle 1, circle 2. And both of them have the same radius r. The tricky bit is this, the stuff that makes cylinder a cylinder is the outer covering of cylinder. When you open that up, when you flatten that up, it becomes a rectangular sheet. It becomes a rectangular sheet. So just think of an A4 size paper and you roll it and it becomes a cylinder, right? So eventually it's a rectangular sheet that you're holding. And rectangle is length times width. So the height of the cylinder is actually the width of this rectangle. And if you look at it, this top boundary, this top length of the cylinder rolls to become a circle. When you roll it, becomes a circle. And the outer boundary of the circle is its circumference. So, for a cylinder, the length of this rectangular sheet is nothing but the circumference of the face of the circumference of the circle, which is either top or bottom. And what is the circumference of the circle? 2 pi r. And therefore, the length of the cylinder is actually the circumference of the circular face. And what is the area of this rectangle? Length times width. Now, what is length? Length is the circumference, 2 pi r. And what is the width? Width is the height of the cylinder. So actually, the area of this rectangular sheet is 2 pi r h. 2 pi r h. And we know that the area of circle is pi r square. And this is also pi r square. So now I've got three things with me. The rectangular sheet. So the rectangular sheet area is 2 pi r h, and circle 1, the top circle, and circle 2, the bottom circle. What are the area of circle? Pi r square, pi r square. And I'm not just going to add them. So pi r square and pi r square becomes 2 pi r square and 2 pi r h. That is the total surface area of a cylinder. So in order to find the total surface area of a cylinder, you just need two things. You just need two things. You need the radius of the base as in one of the faces, one of the circular faces. If you're given the diameter, divide diameter by 2, you get the radius. And just need the height of the cylinder, the h. And then you can apply this formula, and either you can write it as 2 pi r h plus pi r square plus pi r square, or if you want to join them together, you can write it as 2 pi r h plus 2 pi r. Easy peasy. So again, I reiterate, you just need just the radius of the base and the height. Let's do a question, and that'll make more sense. All right, I'm going to get a snippy of a cylinder, and then we'll try to find the area of the surface area of the cylinder. Now, I need to know the moment I see a cylinder, I know that, and I'm asked to find the surface area. I should know the formula first. So the formula is surface area is 2 pi r h plus 2 pi r square. So I need the radius and the height. That's about it. Radius is given to me and height is given to me as well. Let's plug it in. 2 pi times 2 times 3 plus 2 pi times 2 square. Radius is 2. Height is 3. I just subbed it in. So what exactly is this? 2 times 2 is 4 times 3 is 12 pi plus this is 4. 2 square is 4. 4 times 2 is 8. 8 pi. So 20 pi meters square is my answer. That's how easy and how simplified it can be. All right. With that thought, let's try maybe one more, and this time you guys gonna do it. Let me pull a snippy out and see how you. Cool. Here you go now. Can you quickly find me the total surface area of the cylinder, please? Give me the answer in pi, that's fine. I'm calculating it myself. Don't forget to add the units, please. If you're giving me answer, give me in units. It's not 20 pi, Kartikeya. It's not 1153, I guess. So it's not 704, Lakshya. Yes, Zoro, it's 1152, correct. Yes, it's 1152 pi meter square. This time, I was given the diameter. So I need to chop it off. Yes, correct, Abir, 1152. So it is, the radius is 16 this time. The R is 16. And the height is 20. You plug it in and you will get your answer. I'm just giving some more time to other kids to finish before we move on. Quick. All right, everyone's got that? 1152, easy peasy, right? Good. All right. All right. Let's now get into another question. Yes, 1152 is the right answer. All right. I'm just taking a snippet of this one. Let's see how you go. Here you go. Now, I hope this is sort of clear to you all. You all are able to see that, right? Go for it. There you go. I think you should be able to see it now. If it is blurred, log in, log out. Log out, log in back, please. It says the concrete pipe is shown as the diagram below. And you've got some measurements. Now, this T, this is slightly different here. You see, you've got this T. That's, you know how it is how a pipe is, right? So pipe is hollow from the center, but it's still got some thickness, right? So this T is the thickness of the pipe. And this D is the internal diameter. So think like this. You've got a pipe like this. I'm sort of simplifying the question for you. You've got a pipe like this. You're given this is D. You're given this diameter. This is D given to you. And also, you are given this thickness, the T. So D, this T is 30 mm, whereas this D is 18, is 18 centimeter. I need to find the outer curved surface, and I need to find the inner surface. Go for it. Try this. It's not donus. It is annulus is the right, yes, and it is annulus in 2D, not donut. Give me the outer first and then the inner. Give me A and B, both. See the inner curved surface area, it's still a cylinder. Kinetic, it's still a cylinder. So it's asking you, and it's giving you the length as well. It's giving you the length. It's giving you this. This bit is given, which remains same, but both of them, which is 27. So you know the radiuses, you know the radius of the inside, and you know the thickness that can help you calculate the radius of the outer, and you know the height. I'll solve it, don't worry. Go for it. Give it a go. Yes, Zoro, that's the right answer. Yes, you can leave it in the pie. That's okay. Up to you. Give me in pie. That's fine. If that's comfy, give it in pie. Nitin, not right. Check your answer. No, the inner part's not 324. Give it a go. All right. How many did not understand this question at all? Can I see it on the chat, please? How many did not understand this question at all? If you don't, just let me know, right? I'll see. And I'll simplify that for you. All right. Let's understand this. Let's understand. I need to hear a yes and a no, okay, on the chat. I am outlining something in green here. The inner cylinder. Probably I'll take this green off. The inner cylinder. Can everyone does everyone understand that the inner outlined green object is a cylinder? Yes? Yes, the green one is a cylinder, right? Whosoever is not understood, you need to follow this step by step, that I'm doing. So you have to be yes and no. So the green one is a cylinder. Probably I'll take a green color. Green is a cylinder, the inner cylinder. Now, since whosoever said no, can you tell me what is the radius of the inner cylinder? And if you don't know, say I don't know. And I'll let you know what the radius is. Can you tell me the radius of this inner cylinder? Yes, radius is 9. Why? Because the diameter of the inner cylinder was 18. So radius is 18 divided by 2, 9 centimeter. Good job. Now, can you tell me what is the height of this green cylinder? Just let me know the height, the number. Just the height. Shall we not 27? Height. Yes, height is 7. Is 7 the height, everyone? Yes or no? This has to be understood. Quick. Yes or no? We've got 4 minutes in hand. Awesome. Now, what is the formula? Formula for the surface area of the cylinder is, the green cylinder is 2 pi r h plus 2 pi r square. Let's plug it in. 2 pi, r is 9, height is 7, plus 2 pi, r is 9 square. Let's solve it. What does this become? Can you quickly solve it? How many pi's now? So 126 pi's here, plus 81 times 2. 162 pi's here. Yes? The height is 7, yes. So now you have the surface area of the inner cylinder. Am I making sense? But, so how much is this now? No, I think this could be different. Let me quickly do it. 7 times 9 is 63 times 2. Yes, 126. Now, we have missed a very fundamental thing intentionally. I told you this is a pipe. It is hollow from inside, right? It is hollow from inside. So that means there's nothing here. They're hollow, right? So this actually does not exist. Did you see the trick? This does not exist. It's a pipe. It's hollow. So so there's no face here. It's empty. It's hollow. Height is 27. Sorry, I might have taken it wrong. My bad. Sorry. Yes, height is 27. Thank you very much for correcting. Height is 27. I correct that. 27. So the point I'm trying to make is that this bit here does not exist. Yes, Kinetic, picky, I've fixed it. Height to 27. Thank you. So this does not, we don't require this. So the only thing that we need is 2 pi r h. That's about it. It's a hollow pipe. Am I making sense? So this is 2 times pi times 9 times 27, whatever that is. Maybe 600 something, right? How much did you say? 6, what, 6 or 6 or 4? 486, right? Whatever that is. 486 pi. The pipe is hollow. All good? And what about, let's quickly check the outer. And I'll change the color of my pen. You see, if I just draw the cross section, this was 9. And you're given this thickness to be another 30 mm, which is another 3 centimeters. So this big diameter, this big radius is 9 plus 3, 12 centimeters. Yes, you can go. So finally, the surface area of the outer cylinder is just 2 pi RH. It is still hollow. I'm not adding the pi r square here as well. 2 times pi times r is now 12 and height is 27. And that comes to 648 pi centimeters. With that, I finish my lesson today. Thank you very much for joining, and giving your time. Now, on the WhatsApp group, it is not a quiz that's coming to you. You are being thrown questions at a daily basis. You're giving 5 or 7 questions on a daily basis till the time the selective school exam, if you're preparing for that. You should be attempting that. And even if you're not, there is no harm trying. You'll get better at it. There are really good questions that are being thrown at you. So make sure you're attempting those questions on a daily basis. Only 5 questions coming your way. That's it, right? I will share the recording of this video. Thank you very much for your time.